All right, we're going to go ahead and get started. Thank you, everyone, for joining us. This is our final part of the webinar series From Evidence to Practice. Part 5 will be unifying the framework, where Angela will take everything that we've been learning in these webinar series and tie it all together. So without further ado, I'm going to pass it off to Angela to get us started.
Thank you. I'm so excited to be finishing this series and pulling everything together. Thank you for everyone who has come along the entire way. Today, we are going to be looking back at where we started in this 5-part series. We're going to revisit the framework and then talk about why we need a framework. Because for math, the standards may not be enough. So we want to look at the framework and look at how that can support some of the gaps that we see in the standards. And then I'm going to finish with where we go from here. It's going to be a quick 30-minute webinar that ping together. So let's look at where we started. One of the reasons I decided to do this webinar is because I have been doing it for over 20 years, but it's only been in the last few years that science of reading has really moved to the forefront of conversations in literacy. And I wanted to revisit how that came to be and why, and what that means for what's going on in math. So in the first part of our series, the Introducing the Framework, we looked at why we started hearing science of reading so much everywhere, and so much so that now many state legislatures have legislated and mandated that reading can only be taught in public schools using science of reading curriculum, science of reading research. And the question is, how did that happen and why? So just like in math, where you hear about the math wars, there has always been these conflicting pedagogies around how literacy should be taught, how reading should be taught. And the one that got the most adoption in the United States in the late 90s and early 2000s was something called reading recovery, which was started by a woman named Marie Clay in New Zealand. She has since passed away. But this method of teaching reading rejected the use of phonics, rejected teaching students reading beginning with phonics, and instead employ this methodology called cueing, which is really helping students figure out what a word is in the context of what they were reading. But what often happened with students in this reading methodology is that they would just start guessing what the words could be based on what they've read. And cueing didn't help students as they moved away from books with pictures to just books with words. But where this really came to a head was during the pandemic, when parents were home watching their kids being taught reading online, and they were alarmed, and they started asking questions. They started really agitating for a better understanding of how reading was taught, and they were also seeing that their children were actually were not learning how to read. But in 2022, a podcast series came out that just changed everything. This podcast is called Sold a Story, and it looks the stagnating and declining literacy rates of children in the United States and why and how that happened. And they did a deep dive on these two methodologies for reading, science of reading and reading recovery. And found that there was no scientific basis for students learning how to read using reading recovery. And in fact, it could be harmful and dangerous. And in fact, science of reading had a very robust research basis for how children come to learn how to read based on neuroscience and a lot of studies around that. And it really was kind of the straw that broke the camel's back in terms of the reading recovery wars, and a lot of dominoes started falling. So for instance, Columbia University closed down its very big reading headquarters headed by Lucy Calkins, who was just known all over for her reading work, and Fountas and Pinnell, who I believe were out of Ohio, did a lot of work with Heinemann Publishing Company, also, um, just imploded. And as a result, there have been many lawsuits around how to read, and states and publishing companies have been sued by parents around this pedagogy. So, what does that mean for math? Is there a corollary in math? And there is, it's just not as robust. And this is kind of the trajectory of the math wars in the United States. They first started with a very seminal book in 1993 called A Nation at Risk that basically said that we are not teaching our students math um, at the level that will keep our place in the world, our number one place in the world. And that started a lot of changes in what is happening. It happened in math. And in 1989, National Council of Teachers of Mathematics introduced the Principles and Standards for Mathematics, which was the precursor to the Common Core. It didn't go far enough, or it missed the mark, because within 10 years, there was an open letter by mathematicians and professors across the country that said, this has to change. This is not working. And between 1999 and 2010, there was a lot of work done on coming up with common core standards for teaching math. Prior to this, every state did their own thing. Every district did their own thing. There was not one common document that we could go to and say, this is what it means to teach math. This is what it means for students. But almost as soon as it came out, there was a lot of pushback. And a lot of the pushback was about states being told what they should do. There was a real pushback against this national standardized Common Core program. And so all the states then started creating their own standards. So we have the Common Core standards, and then we have the 50 individual state standards that came out. But the question is, like, that's happened. Why hasn't there been this big movement like we saw in Science of Reading that kind of shifted how we teach math? At this point, by the time students leave elementary school, greater than 60% of kids are not ready and prepared for middle school math. By the time they leave middle school, that number is greater than 70% in the aggregate. And by the time students leave high school, more than 80% of students graduating from high school now do not have the foundations and the proficiency in math that is expected at that grade level. So why hasn't something changed? So I think there are three reasons why. The first is that even though parents saw their children learning math during the pandemic on the computer, two things may have happened. One, they themselves didn't do well in math, didn't really enjoy math, and recognized that math is a tedious, difficult thing. And so they were okay with necessarily doing well in math, not necessarily enjoying math. As opposed to reading, most teachers, parents who are engaged in their students learning online are readers. I'm like, wait a minute, I know how to read. Everyone should know how to read. That is not the sentiments for students in math. Like, there is just this kind of understanding that some, or this belief that some students are born as math people and others are not. So I think that's the first reason. The second reason is that I don't believe administrators are moving math to the fore at the same way that they are doing reading. I was at a conference where there was a 16 um, person panel of superintendents who were talking about their priorities for their district. And all 16 of them, all 16 superintendents said literacy, literacy. And if kids don't learn to read by third grade, then, they don't, they're not going to do well. And I asked the question, I said, what about math? Because the top 15 paying majors out of college all are math related majors. Why aren't we looking at math? And not a single superintendent said or acknowledged that that is a priority. It is not a priority. So that's one of the other reasons why we're not going to see that. And the third reason is that there just aren't as many people doing research in math education as there are in reading. So we're not going to see the big leaps happening in math that we saw happen in reading that could make this shift. So the question is that a problem? There is a problem. And one of the problems is that when I do work with middle school and high school teachers, I have them do an exercise. And I shared this in the first webinar series of the series. I have them do an exercise where they identify all the possible math skills a student should learn by the time they leave fifth grade. And we end up with a board of 40 or 50 discrete math skills that students should learn by the time they leave elementary school. And then I ask these teachers to come up with the top three. Take from that list, if elementary schools could only teach three things, what would they be? And they would come up with the top three. Now, when I do this exercise, I say, okay, let's see if your top three skills match what I have on my slide. And I can do this exercise anywhere in the country with any group of middle school or high school math teachers, and they will always say the same thing. It is always the same. Those top three skills are automaticity, basic fact recall. Automaticity is the number one thing. These are in order. The second is a deep and flexible understanding of fractions. And the third is reasoning, but a particular type of reasoning that is, does this answer make sense? That's a reasoning that requires mental math fluency. So automaticity, deep and flexible understanding of fractions, and mental math fluency. Those are the three things. So like if you send kids to us with that, we can take it from there. We can do pre-algebra. We can do algebra. They will be ready. So when we know that these things are there, the question is, can a framework help us to put these things in place so that by the time kids leave fifth grade, they have at least hit the top three skills that are needed by middle and high school teachers to successfully teach math. So when I was doing my research, I do a lot of work around students with weak math foundations. I do a lot of work around how children learn math. I leaned a lot on the frameworks that were provided by Science of Reading. And I have been a Science of Reading fan for 2 decades and started building out our framework for math by looking at the research and the framework provided for reading. And I said, if teachers had a framework, a roadmap like they get in reading, we could really move the needle. So this is a framework that we came up with. It's easy to remember. It's CRAFT. And it stands for counting, reasoning, automaticity, fluency, and tenacity. And you could take each of those parts. Those are the parts that make up a whole math learner. And we can break those down on what does it mean for counting in first grade, second grade, third grade, fourth grade, fifth grade, automaticity for all these grades, reasoning for all those grades, tenacity. What does all of this mean? And we can give teachers a better roadmap for moving the needle in math than we currently have in the current standards. So this is how our framework correlates with Science of Reading. Counting is similar to phonemic awareness and phonics. It is before you learn the words, before you learn to read the words, you learn what the sounds are. This is before the reading, before the words. You learn the sounds, you learn the letters, you learn the blends, you learn all of that. And that's the same with counting. Before the operations, you should be fluent in counting. Children should be fluent in counting by many different units, forward and backwards. Counting is the backbone of learning elementary math. Reasoning is the same as comprehension. Automaticity, same as sight word recognition or vocabulary. Fluency, same as fluency in reading. Another way of speaking as orthographic mapping. You have this ability to look at a word you've never seen before, and you can read it. You can sound it out and you can read it using all that you learned before. And then for math, tenacity is another piece that is not part of reading, but it is absolutely something we want to build in math. So where are the gaps? So if we say this is a framework, these are all the parts that make up the whole of a math learner. And this can be useful in an elementary classroom to help teachers like move the needle. The question is, where do these show up in the standards? So when I started this series, I wanted to look at the Common Core standards, but since 50 states have come up with their own standards, I said, let's look at some of the others. So I chose two, Texas and California, because they're both very large states. They both have math wars. Texas has wordly rejected the Common Core standards. I was told if I ever say Common Core standards in Texas, they will kick me out of the state. So they have rejected Common Core standards. They have created their own standards. California was ground zero for the math wars, where parents really came up in arms around how math was being taught and wanted to shift that conversation. So California and Texas are unique in history in terms of how they came about with their standards. So let's look at uh, the framework of craft and if these things show up in the standards. Now, each of my sessions looked at one of these letters and looked at what it meant. We looked at videos of students and what proficiency looks like, and then we provided what those expectations are. So let's look at what the standards say around that. In counting, counting, which we say is the most critical foundational skill for students. A student should leave elementary school being able to count to any number, by any number, from any number. Counting only shows up in the standards in California, in Texas, and the Common Core up to grade 2, and then it disappears. But it should be a foundation in all of elementary math. In fourth and fifth grade, students should be counting by different units that are not whole numbers. They should be counting by fractions. They should start to learn and understand that counting goes past 0 into the negative numbers. And so counting is really the map that is laid in a child's brain upon which all other math is built. And so the reason we really advocate for a framework is that counting is treated very lightly in the standards. And if it is not in the standards, we know it's not being prioritized in class. Reasoning. So reasoning is all throughout the standards K-12. Um, they talk about being able to solve problems, being able to communicate their thinking, be able to reason, all of that. That is all throughout the standards. But what is missing, and when we talked about this in part 4 of our series, is that in order for a teacher to be able to identify if a child is reasoning at an appropriate level, if a fourth grader, if their communication, their explanation, if their approach to math problems is actually on level, then there's a big piece that's missing from the standards, and that is vocabulary. And that we know that vocabulary grows starting in kindergarten through all through 12th grade. But by fourth or fifth grade, a teacher should be able to listen to a student explaining their thinking and reasoning and be able to say, yeah, that kid is reasoning on grade level because they are accessing this vocabulary to explain this concept or to explain how they came to this solution and they're on grade level. Or they could say the student is reasoning, but not on grade level. They're reasoning at a first or second grade level because they have not developed fluency with the vocabulary that can propel their reasoning and understanding. So vocabulary is a big piece, and it is missing from the standards. For automaticity and fluency, again, those are two of the top 3 skills that are requested by middle school and high school student teachers all over the country. They are 2 of the top 3, and they are very lightly treated in the standards. Um, in the Common Core and Texas standards, they appear only twice in grade 2 with addition and subtraction, and grade 3 with multiplication and division. And in fact, the Common Core standards doesn't talk about subtraction, doesn't talk about division. In the Texas standards, they do talk about addition and the corresponding subtraction, um, multiplication and the corresponding division problems, but Common Core is just addition and multiplication, no by sight. They're basic ones. That's all. In California, they don't use the words know from memory or automaticity, and they simply talk about procedural skill and fluency. So there are no clear standards and expectations by grade level for what it takes to get kids to that point so that we can send them to middle school ready for middle school math. Um, None of the 3 sets of standards talk about mental math fluency. Fluency is talked about, but in a very general way, which makes it ambiguous for teachers in implementation. It makes it very difficult for teachers to implement an understanding of what fluency actually means. We need to know exactly what that means. Finally, tenacity, persisting with challenging problems. This again, also referred to as productive disposition, is all throughout the standards. And we only say, I have nothing really to say about this, it's covered very much in the standards, except that it can often be communicated to schools and teachers around students sticking with doing worksheets, tedious worksheets. And that is not tenacity. Sticking with worksheets where you're just working on developing the tools that you need to use for problem solving is not tenacity. Tenacity is being given challenging problems for which you use these tools to solve, and you persist through those problems. So there could be some clearer articulation of what tenacity or persistence means in those standards. So my question is, what can we do? And in this series, we took each one of those areas, counting, reasoning, automaticity, and fluency, and gave grade by grade level expectations, which I'm going to share now. So for counting, it is really possible for teachers to enact these counting challenges for students that can move them along this continuum and have them develop that foundation. We started focusing on counting when we realized by third grade students were not learning the minute math, the drill code just didn't work. There were kids who got it, and the kids who didn't never ever got it. And when we started looking at why they didn't get it, it's because they didn't have this foundation of counting. And when we started focusing on building students' counting foundations forward and backwards, we found that once we did that, it was very easy for students to develop their automaticity and multiplication and division because we were counting by all their multiples. They were learning their multiples, and they subsequently were able to attach those to the multiplication and division problems that they were learning in third grade. So that by the end of third grade, students should be fully automatic, just like in reading and sight words. They should be fully automatic in their addition, subtraction, multiplication, and division basic facts. For reasoning, we look at reasoning as something that begins in kindergarten and can be measured beginning in kindergarten, but is approached differently grade by grade. And in kindergarten, students are very prepared and skilled at problem solving when it is presented to them without words, when it's presented to them where they read it out loud, and when it's presented where they can directly model or act out the problems. So directly modeling a problem means giving students objects that they can manipulate to solve the problems, or having the students physically act out the problems. And reasoning at this level introduces algebraic thinking with if-then scenarios that are mostly tied to ordinality, order in line. We call these position in line types of problems. And so we start building reasoning in first grade with those types of problems that don't require reading, don't require writing, but allow students to directly model at a higher level. Um, by second grade, same as first grade, but students are beginning to have these stronger reading skills. We still don't use a lot of words, but students should be able to read and solve these problems independently. And we introduce critical thinking with algebraic reasoning using if-then scenarios that is not just ordinality, but now with operations, addition, and subtraction. Third grade, they need to have all first and second grade reasoning ready, and now being able to reason using all four operations, if then scenarios, algebraic reasoning by third grade. If students don't have their reading down by third grade, they are not going to be able to reason mathematically at a third grade level. They can still reason mathematically, but it won't be at a third grade level. And then fourth and fifth grade requires a robust understanding of math vocabulary and notation. There's a lot of math vocabulary that we expect students to be able to access and use in solving problems that have a lot of math vocabulary in it. And in our webinar last week, where we talked about reasoning, I shared examples of what that looks like for fourth and fifth grade. If we do this, students will be walking into middle school ready for middle school math. Automaticity, by the end of 3rd grade, I'm just gonna say very quickly, by the end of 3rd grade, we expect students to be fully automatic in addition, subtraction, multiplication, and division. This is something that should be assessed, and if students don't have it, it then becomes an intervention. And in 4th grade, it is an intervention. We've got to get kids up already there. It is not okay. It is not okay for students to be using hash marks, to be counting on their fingers to solve their basic facts when they're in 4th grade. And this has been communicated to schools and teachers, and they're like, as long as they have a strategy for finding the answer, but that is absolutely wrong. And I tell teachers to use that same reasoning for reading. If you said, well, as long as they have a strategy for sounding out their sight words that they didn't learn, for sounding out words that they didn't have, they don't have orthographic mapping, they don't have vocabulary, they don't have sight word recognition, but as long as they have a strategy, they'll be fine. But we know that they won't be fine because you can't open a book and read it with any kind of understanding if you're stopping at every third word to try to use a strategy to figure it out. And that's exactly what happens in math as well. So that's automaticity. Finally, mental math fluency is see it, know it, do something with it. And these follow me activities are examples of how we monitor progress toward mental math fluency at grade level. And these are cards that are read at a certain speed, and students have to be able to do 3 in a row for us to say they've mastered that level. So, mental math fluency. So that kind of pulls everything together in what we did in these 5 sessions of this webinar series. But another thing that you can do, if you're like, what can we do to address this issue, particularly in elementary school, but we also help middle and high schools work with kids who come with weak math foundations. You can schedule a meeting with us, and we would love to share more how your teachers can move the needle because a framework is needed in addition to our standards to help us accelerate math achievement. So thank you so much.